Welcome to this video all about voltage drop formulas. Okay, so the first formula, we're starting with voltage drop. Voltage drop equals 2KIL over Cm. Of course, the VD stands for voltage drop. The 2K is a constant where the K represents the ohms per mil foot. But what you just got to know is 2K. That's always going to be in here. It's a constant. I stands for current. L stands for the length of the wire in feet. And Cm stands for circular mil of the wires. If you want to have a table where you could see this, go to chapter 9, table 8 of the NEC codebook. Okay, so we're going to want to know every single one of those. We're going to want to know voltage drop, the formula for that, which we see here. We're going to also want to know the formula for current and for the length and for the circular mils if we had each of those as what we were trying to find, solve for, or in other words, that was the subject of the formula. Now, instead of memorizing 4 different formulas, which I think is already kind of a headache, we could just memorize this one formula and create all the formulas out of it. And it's actually really simple. Okay, so watch what I do. We're looking at voltage drop equals 2K, that's one unit there, okay, times I, current, times L, the length. And this is in feet. Okay, this is over or being divided by circular mils. So right now it would be accurate to say the subject of the formula is voltage drop, because that is what everything is equal to. Okay, this really is very simple. So we're going to make the subject of the formula L. We're going to say solve for L. How are we going to do this? Okay, well, first of all, we know voltage drop is by itself. Everything's equal to that. On the right side of this formula, we see a fraction. We know the top part of this fraction, the numerator, is being divided into the bottom part, the denominator. So therefore, we can break up the top section in separate units, such as the 2K times I times L. Those are 3 different things being multiplied. We're going to get into that in a second, but what we do see is all of that being multiplied divided over Cm equals voltage drop. I mean, this is kind of obvious, but it's good to think about it in this way. And because of this, the only way that this would make sense to move anything, because I'll remind you, we got to move something to the left side here, because right now we just have voltage drop equals this. Okay, we need to move stuff around. So we're going to have to move something over to the left side, and this is how we're going to do this. Because this whole top part is dividing into this bottom part, we can get rid of the bottom part because we can look at this as 2 separate sections. The top part of the fraction and the bottom part of the fraction. And before we think about doing anything to the top part of the fraction, we need to realize if we get rid of anything on the top, it's not going to make sense, because right now this formula is saying this VD is equal to this whole thing on the top divided by what's on the bottom. So if we move anything over, it's not going to make sense, because this thing together equals voltage drop. Okay, this fraction equals the voltage drop, or the ratio, whatever you want to call it. Okay, so therefore, it's a rule. When you're dealing with a fraction, you're not going to move your numerator to the other side of your equation, and to think about it logically. So it's good to write things out in different perspectives. So let's take 4 divided by 2. Very simple. And we obviously know that's 2. But the point of this is, if we wanted to move one of these numbers to the other side of the fraction, well, we could obviously see 2 times 2 equals 4. Okay, that makes sense, because you're taking this multiply here, and you're saying 4 divided by 2 equals 2. So because of that, 2 times 2 equals 4. Okay? But you obviously can't take 4 and move that on the other side and say 4 times 2. Because when you're moving something on the other side, you're doing the opposite of what's there. And when you're taking the opposite of the divide by 2, you're going to multiply by 2, of course. And that makes sense. Okay. So you get multiplied by 2 on the other side. But what doesn't make sense is when you try to get the first number in this division problem and you try to move it over. Because there's nothing in front of it. Okay, it's not being divided by. And division, you can't change around the numbers, okay? You can't do 2 divided by 4 and get the same answer. You have to keep it 4 divided by 2. It has to stay in this order. So because of this, the only thing you'd be able to do is look at 4 in the state that it's in. It is a positive 4 where it is. It's not being added by, but technically if you wanted to say subtracted by 4, Well, you could not do that because you'd be left over now with divide by 2 equals 2 minus 4, and obviously that makes no sense. Okay, so all that is just to prove that you never are going to move the top number of your fraction. It just doesn't make sense. Or if you look at it as division, which is what it is, it's not going to make sense to do that. Because of that, we want to get rid of this bottom number, the denominator, okay, because everything is being divided into this. So look at it as dividing. I think this is a big division sign, so we can do the opposite of that by multiplying, which is going to counteract it. So we have multiply by CM. That is going to cancel it out on this side. But what we do on one side, we got to do on the other side. So now we got to multiply the circular mils on the other side. Okay, now we come up with the formula voltage drop times circular mils equals 2KIL. Well, we want to solve for L. Okay, so what can we do to now isolate L furthermore, or maybe we can do it all in one step? And yes, we can. One thing we got to comprehend here is we have all of this being multiplied together. We have 2K times I times L. Because of this, you can switch around multiplication and it makes sense. Okay, you can always switch around addition and multiplication and it makes sense. Okay, like if you have 2 times 2 times 2, or 2 plus 2 plus 2, you can switch around all those, or any number. Okay, and you're going to get the same exact answer at the end of it. So you can always switch around multiplication. The significance that this has is that when we're looking at all of this being multiplied together, we can think about dividing any of this, which would cancel it out and bring on the other side. But furthermore, what we can do is we can pair together any of these and divide them together. Because what could be happening is this can be paired in any order. And this actually is an order that is going to be nice right here because we have 2KIL. Okay, so we could look at this as 2K times I times L equals the left side of this formula, and we could look at the 2K and the I as one section saying 2K times I, then times the L, okay, which is a separate section because it's all multiplication. What I'm saying here is then we can get rid of the 2K and also the I. Okay, I actually should put the little things on top of the I to show you it's an I. But because it's multiplication, we can just say, okay, we can get rid of any pairing of these things that are being multiplied together and then cancel them out and move it on the other side by doing the same thing. So now on the other side, of course, we have divide by the 2KI, which that's going to leave L, okay, all by itself. Okay, so now I'm going to rewrite it with L starting on the left side. Now we have L equals voltage drop times the circular mils, and that is just over the 2K I current. Okay, and this is your final answer. That is your formula to find the length when you're thinking about a voltage drop situation. This is when you already have your voltage drop, your circular mils, and you're using that 2K constant, and you also have your current. Now you can figure out the length. So this is another one of those things where you can figure out one thing that's missing if you have the other things that fill in the gaps. And with this, you only have to memorize the one formula. If altering around the formula seems a little bit weird, I have a whole video on this, actually my last video, called How to Rearrange the Subject of a Formula, or something of those terms. Be sure to check out that video. It's a really good video. There's a lot of examples in there, things that you wouldn't normally see, things that are a little more rare. Even simple things like when you have two fractions next to each other, what's a good method for solving for that? And let's say when you have the same variable on two different sides of an equation, well, how are you going to then combine them basically on one side of the equation and solve for that one variable? Then let's say you had another situation where you had one variable and another variable that's mixed with other variables. So for example, say you had 2kz and then you had 5z, okay? And you wanted to figure out how to combine these in a formula somehow. But one of them is kz and one of them is z. What are you gonna do? So it talks about that in the video. So of course we're using that, how to rearrange the formula. Okay, we're gonna look at the next one. But just remember the formula is voltage drop equals 2KIL over Cm. An easy way you can remember this is just think voltage drop equals 2 kil Cm. Like let's say voltage drop had a plan to kill circular mills. Okay, because we don't like circular mills, it's weird. Who likes using circular mills? So whatever you want to use to remember it, I just remember as voltage drop equals 2 kil circular mills. I don't think of it like a whole story significance. It's really actually pretty simple. It's just 2 kil. And it's not KILL, it's just KIL. Because you don't need the two L's. It's pretty obvious, kind of explains itself. And then over circular mills. That's the only thing that you need to know. Okay? There's going to be one other thing that I'm going to show you at the end of this, and that's going to be define resistance. And all that you're going to do is memorize this, and there's going to be one slight difference. That's it. Okay, so next, we're going to actually basically do something very similar, and it's going to build off the last one. Okay, so now we're going to think about finding current. So in other words, solve for I, make I the subject of the formula. Here we see I is in the middle of this group of numbers being multiplied, and if you remember what I just taught in the last one, well, this won't be much of a problem, but let's get into it. Okay, so we want to isolate I. And I is existing in this group of variables that are all being multiplied, and those all being multiplied together are being divided by the circular mills. Of course, all of that together equals the voltage drop. So we want to change something, we want to isolate I. Of course, again, this is all existing as a group on the top. We can't just change anything around because right now, that as a group divided by the circular mills equals the voltage drop. So therefore, we can change what this is being divided into. We can change the denominator. Okay, so we're going to do times circular mills because it's being divided into circular mills. That's going to cancel out circular mills. What we do on one side, we got to do on the other side. So now we're going to do times the circular mills here on the left side of this formula. Okay, so now we get voltage drop times circular mills equals 2 kil, or 2 KIL. So it's very similar like the one last time, but now we want to solve for I. So how are we going to further isolate I? Remember what I was saying is these are all being multiplied together, so we can rearrange them any way we want. Therefore, we can imagine this saying anything in any order. Simply, we could say 2k times L times I equals what's on the left side. Okay, so because of that, we can, again, divide by any one of these because they're being multiplied, or we can pick any grouping of these, such as the 2k and the L. Okay, and do divided by 2k times L. That's what you're doing here. Of course, it's going to cancel out the 2k and the L. You're going to do the same thing on the other side. Divide by the 2k L. And now, of course, rewriting with the I on the left side. Now we have I equals the voltage drop times the circular mills over 2k L. And that is your final answer there. So you see it's all really simple, and I'm taking some time to explain it, but in real life it'll be very quick and you won't have to think about it much. I honestly think it would take more time to try to remember each of the 4 different formulas and remember exactly which of the variations you're working with versus just remember voltage drop equals 2 kil over Cm. Okay, pretty easy. Okay, last thing to solve for from this formula that we're looking at right now, and that would be the circular mills. Because the 2k is just a constant, you're not going to solve for the 2k because that's just a sort of placeholder in the formula. So circular mills is something that we might want to find. Therefore, now we're going to try to find circular mills, make circular mills the subject of the formula, in other words. Okay, so now this is different because, like I was saying in all the other ones, the first thing that we want to do is multiply by Cm to get the Cm on the other side, and we have to do that because all this exists as a group. We can't change the top of this. It wouldn't make sense, okay, mathematically, when you think about it. The best way to think about it is draw this yourself and then plug in actual numbers in representation of each one of these instead of the variables. Then when you rearrange everything, you'll start to make sense of why it makes sense to move certain things and it doesn't make sense to not move certain things. If it doesn't already make sense with what I'm explaining, don't worry, just start to plug in numbers. Figure it out yourself. Okay, so now this might seem kind of weird, but it's actually extremely simple. I left basically the simplest one for the last. So this one's basically the simplest one. So what can we do? We have voltage drop by itself. We can't move that. That wouldn't make sense. It's not, nothing's happening to it, and it would be by itself. And of course, like I was saying, I keep saying this, you cannot change the numerator or the beginning of the division problem. Even if it's a bunch of things being multiplied, divided by something else, you can't change any one of those, which it's good insight into that. If this was written horizontally instead of vertically, so we had 2k times I times L divided by CM, again, you got to think about the insight that you cannot change any one of those things being multiplied together, dividing into the other thing. It just doesn't make sense. Okay, so it sounds kind of like a bunch of mumbo jumbo. What are we going to do? We're going to multiply by the CM. Okay, why would we do that? We don't have any other choice. Okay, when you can't do any other thing in life, you got to do what you can. Okay, so we're doing what we can. We simply don't have any other choice. Now again, we're going to get voltage drop times CM, and that's going to equal the 2 kill. Okay, now you might already think about what's going on right now, or you might be confused and wonder what the heck are we going to do, or why did we just do that, because it seems like we're doing the opposite of what we want to do. Okay, so we want to solve for circular mills. Again, we can rearrange anything in multiplication. So I could have written this as CM times VD. We think about numbers, I say 3 times 2 equals 6, 2 times 3 also equals 6. Okay, so in multiplication, you can rearrange these any way you want. Because of that, it would make perfect sense to say, I'll just get rid of the voltage drop by dividing by it. Because again, this could have been CM times VD. Doesn't matter. And now on the other side, I'm going to have 2KIL over VD. So now rewriting this with the circular mills on the left side of the formula, we're going to have the circular mills equals the 2 kill, 2K, IL, and that's now going to be over the voltage drop. So it's basically what we started off with, except the circular mills and the voltage drop flip around. Of course, you could remember that, but if you know how to solve for this, you could think about it in your head literally, really quickly, what I just did, when you comprehend it, and you can double check. So you can say, I'm pretty sure that it's just these flipped around, and then you can think about, okay, voltage drop equals 2 kill over CM, how you begin with, and then you could think about what I just showed you real quick, and you can think, oh yeah, and of course, this is the final answer there. Okay, so now we know the formula for voltage drop, we have that memorized, and if we want to have current, now we know how to solve for that, and for the length, we know how to solve for that, and now we know how to also do these circular mills, which is basically just flipping with the voltage drop. Okay, so last formula on this video for the voltage drop formulas. How do we find resistance when we're thinking about the voltage drop circumstance? And for this, we just need to think about the same formula, the 2 kill over CM. But in this case, all that we're going to think about is the I is gone. So you can think about there's no current in the equation. If you're thinking about the saying like the 2 kill, you could think that the vowel is missing. So like when you remove vowels and things, it becomes like the text message version, to where instead of having 2 kill, now you have 2 kill. Okay? So it still is the same message, but it's like a text message version. Just little things to help you remember. Okay, so when we want to find resistance, think 2 kill over CM again, but 2 kill CM, or in other words, 2KL over CM. That's that simple. That is the formula for resistance when you're thinking in terms of voltage drop, and because of that, all that you need is your length and your circular mills. Okay, now I have all the formulas that I talked about in the video, as well as some numbers that we can plug into each one of these variables, and we can figure out each one of these. Okay, now since K or 2K is a constant, we're not going to solve for that. We're going to use that in the formulas when we need to. But what we are going to find is I, L, CM, and voltage drop, as well as the resistance. Okay, so now we're starting with I. I normally rewrite the formula, but we can see it's right here, so it's basically like it's already written out. So we're going to plug in the numbers. We have the voltage drop, which is the 6 volts, times the circular mils, which is the 12,000. All of that is over the 2 times K, which is 2 times 12, times the 200 feet for the length. Okay, now you're going to want to multiply the top, then you're going to want to multiply the bottom separately, and then divide those. Okay, so on my calculator, I'm going to do 6 times 12,000. I'm going to get 72,000. Okay, write that down. And then we're going to do 2 times 12 times 200, and we're going to get 4,800. Now we're just going to divide 72,000 divided by 4,800, and we're going to get 15. Okay, so I equals 15, and we're working with current. So we have 15 amps, and just to check that our answer is correct, that is our final answer. We do see 15 amps is what we were given, and that's what we just got when we solved. Okay, so moving on to the next one. I'm going to go in the order of the kill, just to kind of make that memorable, the K-I-L. Okay, so next I'm going to do the L, because of course we didn't do K, and we just did I. So now L, we see the formula, and this time I will write this out. Okay, we have voltage drop times circular mils over 2K I. Now I'm going to plug in all these numbers. Voltage drop, we know that is the 6 volts. The circular mils, again, we have the 12,000. The 2 is the remaining number, and we're using the 12 for copper, so 2 times 12 for the 2K, and then times I. We just solved that, and we have the 15 amps. Okay, now same thing. Multiply the top, multiply the bottom separately, and then divide those, and we'll have our answer. Okay, 6 times 12,000, if you don't remember, we have 72,000. And now the bottom, we have 2 times 12 times 15, and we have 360. Okay, now we're going to do the 72,000 divided by 360. We're going to get 200. Okay, and we have all the numbers given to us, so again, we can double check. And yes, we do have 200 feet given to us already right here. So we solve for the correct answer. And yes, this will be final answer. Next, we're going to solve for the circular mils. And if you don't have this memorized, this will be the formula 2 kil over, now the voltage drop, since compared to the voltage drop formula, circular mils and the voltage drop just flipped around. Now again, we're going to plug in all of the numbers. So we have 2 times the K, 12, times the I, the current, which is again the 15 amps, times the length, which for the length we have the 200 feet. All of this is over the voltage drop, so we just have everything over 6 volts. Now we're going to want to multiply the top. We're going to do 2 times 12 times 15 times 200. Okay, that's going to give us 72,000, and then the bottom is just 6. So now we're going to do 72,000 divided by 6, which is 12,000. And this is our final answer there, the 12,000 circular mils, just like what was given to us from the beginning. Okay, so we solve for the correct answer again. Okay, so last one for the voltage drop. Now you should really know this formula by now, okay? If I tell you anything in this video, you should know this formula memorized. Okay, we have voltage drop equals 2 kil over the circular mils. Now we're going to plug in the numbers. 2 times K, which is 12, times I, which is 15, times the length, which is 200 feet. Of course, the I is the amps. That is all over the circular mils. So we have the 12,000. Of course, you could just write 12K. I'm writing the 3 zeros. Doesn't really matter as long as you comprehend that. Okay, so we have the 2 times 12 times 15 times 200. You probably know what that is by now. That's 72,000. Okay, now we have 72,000 divided by 12,000. Okay, so if we want to think simply, we could just think about all those zeros sort of canceling out. 72 divided by 12, we're going to get the answer 6. You could just think 12 times 5 is 60, so 60 plus 12 is 72, so you obviously have 6, and that is 6 what? That's 6 volts. Okay, we have the same answer that we started off with. Voltage drop equals 6 volts. Okay? Now if I was a bad musician or teacher, I would say end of the video. But you always have to have an encore, okay? When bands just like tell you it's the last song and then they walk off stage, that's ridiculous. Okay, you gotta like kind of hype them up. Like, oh, it's the last song or whatever. And you gotta be like, okay, now here's the encore. Here we are. Remember, the 2K IL formula over CM is very handy. Because remember the resistance is just without that vowel in there. It's like if you're texting. Okay, so we just have 2KL or 2KIL over CM. Now we're going to plug everything in. 2 times K, which is 12, times 200 for the feet over the circular mils, which again is 12,000. 2 times 12 times 200 is 4,800. 4,800 divided by the 12,000 that was on the bottom there is going to be 0.4. And since we're working with resistance, we're going to have 0.4 ohms. And that is our final answer for resistance. That wasn't given to us in the beginning, but yes, that is the correct answer, 0.4 ohms. It's the final answer, and yes, this is the final answer. So I hope you enjoyed this. I hope you learned something. If you did like it, give it a thumbs up. Other people will have a chance to see it. If you have questions, give it a comment. If you want to leave a comment, or you have any critiques or anything that you thought maybe was incorrect, you didn't understand, you didn't agree with anything at all, leave something in the comment section. If you want to personally contact me, instead of leaving it in the comments, contact me at this email. Until next time, take care and goodbye.